Okay, I've had a lot of questions about this particular problem. I think specifically this problem is a car coming to a stop in the rain. But what we're going to do here is, it doesn't matter. This is just the same old three-step problem-solving process. And y'all are starting to get pretty good at that. I've noticed a lot more people starting to use their free body diagrams. And then they got to this far, and then they kind of freaked out a little bit because it does not give them mass. And you recognize that if you don't have mass, I can't find the weight. If I can't find the weight, I can't find the force normal. If I can't find the force normal, then I can't find the force of friction, which is mu k times force normal. Okay, well, you just need to go to your next step in your problem-solving skills, and you need to learn through to carry your unknowns as variables. Remember, in this three-step process, you can really pretty much solve for anything. So if mass is one of your variables, just treat it like one of your forces, or mu k or something, or acceleration or something like that is one of your variables. Okay, so if we do this, all right, we recognize that if we go to Newton's second law, that these two guys, when added together, are going to cancel out. So F net, I'm left over with just this force of friction. So everything cancels out except for force of friction. And that is going to be equal to my mass times acceleration. Okay, well, let's break down the force of friction a little bit more. Well, we learned here that force of friction is mu k force normal. And we see that force normal is in equilibrium with the weight. So it's going to have the same magnitude. So it's going to have the same magnitude of the weight, and the weight magnitude is going to be mg, mass times acceleration. All right, so what am I trying to solve for? I'm trying to solve for acceleration. So my first algebra move is these guys cancel out, and I'm easily able to solve for acceleration. Now I got a kinematics problem, and most of y'all are pretty good recognizing that. I had a V initial that was given in a problem. The V final was equal to 0. Now, there's a number of your kinematics equations that you could use, but the most efficient one to use here would be this one. I'm coming to a stop, so this is 0. Acceleration we computed from Newton's second law. Initial velocity was given. The only thing you need to be careful of in this particular problem, it was given in kilometers per hour, and of course that needs to be converted to meters per second. Okay, so you should know how to do that conversion by now. If not, you might want to do like I did and give up. And we didn't have Google back in the day, but what we did have is we had these Bomb Diggity TI-85 calculators. This particular model is probably older than just about all of y'all. But the cool thing about it is I have this really cool conversion routine on it. And I can take, let's say, 40, and I can choose all these different units down here. Here's some more: mass, force, energy, power. Oh, speed, there's a good one. Kilometers per hour, that's this button, to meters per second, and that's that button. And you just go, oh, wow, gee whiz. Hey, you can do the same thing on Google. You can do the same thing on your TI-80 calculator. Because you can actually download something besides games. You can actually download a scientific unit conversion routine. Anyways, that's how we solve this problem. Thanks.